This is an introduction to unit conversion, something that's very important in physical science, especially physics. Everything that we measure has a unit attached to it, whether it's a vector or scalar quantity, and we'll talk about the differences between those later on. Very rarely do we measure something in physics that doesn't have a unit. A unit is always used when we make a measurement. Very rarely do we make a measurement in physics that doesn't have units. And this is a way for us to define the magnitude of some physical quantity that we've measured. Here's an example, the kilogram. If we measure mass, then we compare what we measure to this standard, which is the mass of a prototype kilogram, a chunk of platinum iridium alloy that is stored in a vault in Paris. So when you make a measurement, you have to express the measurement using some kind of unit. You can't just say that your mass is 60. It would make more sense to say that your mass is 60 kilograms. So you're comparing your mass to that standard of 1 kilogram that I just mentioned. We use the SI system of units, or Système International. These are used in science throughout the world now. Mass, as we just the kilogram. For length, meters, so we measure length in meters, distance as well. For time, seconds. Ampere. Notice that we have short forms for all of these units as well. So kg for kilograms, m for mass, s for seconds, capital A for amperes. For temperature, K. But if we change the temperature by 1 degree Kelvin, it's the same as changing it by 1 degree Celsius. So we will often use Celsius as well, degrees Celsius for temperature measurements. We can also derive units from these base units. For acceleration, we use units of meters per second, or meters per second squared. So we use the base units meters and seconds. For force, we use kilogram meters per second squared, but those are also, which is much more convenient. It's easier to write newtons, or capital N, than it is to keep saying kilogram meters per second squared for using force a lot. For energy, we use kilogram meters squared per second squared, also known. If our measurements are really big or really small, we often need to use metric prefixes that are based on powers of 10. 1 kilo, so kilo means 1,000. Here are some that you really should know: billion, million, thousand, hundredth, thousandth, millionth, and billionth. These are very commonly used. So billion is 10 to the 9, million 10 to the 6, thousand we just saw is 10 to the 3, hundredth is 10 to the minus 2, thousandth 10 to the minus 3, etc. There are others, of course, but these are the ones that we will most commonly use. 10 to the 9 is also giga, which is capital meg, the 6, capital M. Kilo is small k, lowercase c for centi. Milli, which you've seen before as well, is lowercase. Millionth is micro. Notice that this one, for micro, we use this prefix, which is the Greek letter mu. And that's because we use m so often. We needed to find a different m to use. 10 is nano, lowercase n. Here are some other ones that are less common. You've probably heard of tera before, because now computer hard disks, you can buy them by the terabyte. It won't be too long before we're buying petabyte hard disks. Get beyond that, and we've got exa, zeta, and yada. Those are rarely used. On the smaller end of the scale, we've got pico for 10 to the minus 12, femto for 10 to the minus 15, and then it gets smaller from there. Let's try some practice. 2 microseconds. 2 times 10 to the minus 6. You should know how to enter this number on your calculator. You probably have an EXP button on your calculator, and you need to have a scientific calculator or this won't work. So for scientific notation, you would enter this as 2 and then EXP and then -6. For the negative, don't hit the subtraction button. Use the plus/minus button to change that exponent to a negative exponent. You might have an EE button instead, or your calculator might have a 10 to the x button. It won't have all of these, but it'll have one of them. 2NS. What's that one going to be? Let's see if you were right. 2 times 10 to the minus 9 seconds. 2 nanoseconds. 20 ns. Were you right? 20 times 10 to the minus 9, or 2 times 10 to the minus 8. If we write it like this, you'll notice there's a difference here. With scientific notation, there's only one digit to the left of the decimal place. If we have more than one digit to the left of the decimal place, but the exponent is a multiple of 3, or it corresponds to one of the prefixes, then that's engineering notation. So scientific notation and engineering notation. Your calculator will likely convert from engineering to scientific notation for you. So if you put in 20 and then EXP -9, it would probably convert it to 2 EXP -8 for you. Try writing the following here. SI base units, try these out. See how you do. You can pause the video if you need a bit more time. I'm going to go through them now. 4.3 times 10 to the minus, 4.3 times 10 to the positive 6, because that's 4.3 million meters, or 4.3 megameters. 35 times 10 to the minus 2 meters, for 35 centimeters. Or you could write it in these other ways. These are all equivalent. They all mean the same thing. 7 microamperes, or 7 times 10 to the minus 6 amperes. Then 5 times 10 to the minus 4 amperes, which is 0.5 milliamperes. 300 nanoseconds, or 3 times 10 to the minus 7 seconds. Again, we see engineering notation. And then we have scientific notation. Well, to express any measurement in different units, we can multiply it by a conversion factor equal to 1. Here's an example. If 1 kilogram is equal to 1,000 grams, well, we know that 1 kilogram over 1,000 grams is equal to 1. So 450 grams, going back to that last example, we multiply by 1 kilogram over 1,000 grams, and we get 0.45 kilograms. Now, how do we know we want to write the factor in kilograms per gram or in grams per kilogram? Well, we know that we want grams to cancel, and we want to be left with kilograms. So we know that we want to have grams in the denominator and kilograms in the numerator. Let's convert 7.2 hours to seconds. So we multiply 7.2 hours by 3,600 seconds in each hour, or if you want to expand it, you can see we have 60 minutes in an hour, and then we multiply by 60 seconds in a minute. It's important not to round this number to significant digits if you're going to use it for a calculation later on. Don't round too. Sometimes we need more than one step when we're converting units, so we need more. Converting from kilometers per hour to meters per second is something we do a lot in physics. So here's an example: 120 kilometers per hour. Well, first we'll take care of the kilometers. There are 1,000 meters in a kilometer, so we'll multiply by 1,000. Then we'll multiply by 1 hour per 3,600 seconds. And we get 33 meters per second, rather. This method will work for non-metric and even non-standard units. Here's an example. If we know that Ms. Roseberry is 167 centimeters tall, and a marathon is 42,195 meters, how many Ms. Roseberries are there in a marathon? Well, we've got a marathon times 42,195 meters per marathon times 100 centimeters per meter times 1 Roseberry per 167 centimeters, and we get 25,266 Roseberries. Now for some practice.